So let's take a look at some examples.
Throughout this webinar, we're probably going to focus our demos primarily around the DCS. Now that's because if a finger mark is challenging, we're going to need the best of the best to be able to photograph this. So the DCS itself is made up of specialist lighting attachments, a high-resolution camera, and specially designed fingerprint enhancement software that all work together cohesively to mean that we are able to photograph any fingerprint on any background. And that really is why we use the DCS5 when it comes to challenging finger marks. That's what all of us go straight to. So throughout these demonstrations, myself and Laura are going to hopefully show a couple of really useful tips and tricks. So either if you have a DCS, you might be able to use some techniques now that you hadn't maybe thought of before, or what we might be able to do is introduce you to some brand new techniques that you have never heard of or never seen before as well. What we're going to take a look at now is a couple of surfaces that in isolation may well not seem that challenging, and a couple of fingerprints that again in isolation may not seem that challenging. But what we'll do is talk about how we could potentially make that photography a little bit more streamlined and a little bit faster. So in general, after treatment with cyanoacrylate, most labs, the majority of laboratories, are still going to use a dye stain after cyanoacrylate treatment. So the purpose of that is to make the fingerprints easier to photograph mostly. So what will happen is the cyanoacrylate will absorb that dye stain, and hopefully the background won't absorb that. So that means that we don't have to play around with angles and lighting quite so much. We know that, for example, if we used basic yellow 40 as our dye stain, that we're always going to use a blue light to photograph that. It makes it much easier and much more repeatable to photograph those fingerprints. But there's a couple of scenarios where those dye stains may well not help us. They might actually hinder us. So one such scenario, and the one that we will start by looking at, is fingerprints on a slightly porous or semi-porous background that may well absorb some of that dye stain. So normally, as I explained, what we're hoping for from our dye stain is that it makes the fingerprint fluorescent without making the background fluorescent, so that it's easier to photograph. But if our background is a little bit porous, what can happen is that the dye stain can actually sink into the background as well and be absorbed by the background as well. That means that when we come to do our fluorescence photography, our background is fluorescing at exactly the same wavelength as the fingerprint, and it can actually mask the fingerprint and make it much more difficult to see. So what we can do is actually sometimes miss out that dye staining part of the process completely. The first example we're going to look at is some finger marks on a small plastic bag. Now, the white parts of this bag, actually, when we use a dye stain like basic yellow, they can absorb quite a lot of that and cause that problem with the background fluorescing. So we're actually going to skip out that dye stain completely. We're going to use a technique that we speak about a lot at Foster+Freeman, and we speak about a lot in our webinars, but that's because we think it can be incredibly effective for our customer base. So we're going to use reflected UV, reflected long wave UV, to photograph these fingerprints. So the first thing I have done is made sure that the quartz lens is attached to the DCS, and I'm going to swap my visible filter stack for a UV bandpass filter. So all this does is it means that instead of transmitting the visible part of the spectrum, the lens and the filter will only transmit the ultraviolet part of the spectrum. So we're viewing all of those interactions in the UV part of the spectrum rather than the visible. So the final thing I need for this, and I need to make sure I have, is an 82S UV. So I'm going to use this as my light source, and I'm going to move it around and angle it so that I can view the fingerprints on the live feed of the DCS. So what we will see on the screen will actually look quite different to what we will see on the physical sample. So, visibly, we do not see the same result as what we are seeing reflected in the live feed from the camera. So visibly, all we see is quite bright UV fluorescence from the surface. However, I capture a preview, we can now quite easily see the ridge detail on this surface. So what's happening is that the cyanoacrylate is actually scattering quite a lot of the UV light. So a lot of those ridges are appearing lighter than the background. The background is absorbing the UV light. What we can see now, and what we've actually managed to achieve, is to see those fingerprints and the ridge detail, more likely, to see the ridge detail running over the top of those white stripes that are present on the surface of this small plastic bag. It makes it much easier to see the fingerprints on this surface, and we haven't had to wait for a dye stain to dry. So if I now just change the lens that I'm using in the software and capture that image through to the enhancement screen, we can do a couple of really nice and simple enhancements to this image. So the first thing I am going to do is convert this image to grayscale. And if we look at this area of ridge detail here, primarily, and this one here as well, I'm going to, so this is quite a tricky one actually, because this area of ridge detail that we see here is actually already dark, whereas this area here, which is actually the part I'm going to concentrate on, we can see a couple of pores throughout this area here. This area would need to be inverted to give us nice dark ridges on a lighter background. So then we could maybe use our area of interest tool and come to superglue. So the superglue tab, and see if we like the effect from something like enhance. Sometimes that can be a bit much, because obviously we can see quite good contrast in this mark already. So I actually prefer applying that enhancement across the whole image. So what's really important to understand with DCS is when we do something in a small area of interest, the effect might be really, really different to when we apply it across the whole image. So sometimes if you don't like the effect across the whole image, it's worth applying it on an area of interest, and vice versa actually. So then we can output that image into our network location, ready for somebody else to view and look at.